Introduction of matrix. The data can be arranged in many forms to make it look simple and easy to understand. One way to arrange data is in matrix form. The matrix is a rectangular array of numbers with horizontal row and vertical columns. The elements in the array are called entries in the matrix. The size of the matrix is described by the number of rows and the number of columns it contains.
Game theory. Introduction. Game theory is a mathematical study of the options players might make to win in games. Psychologists refer to it as the theory of social interaction, as it seeks to consider in a competitive environment the decision that one player can make against the other. This project will show how linear algebra matrix calculation may be utilized as a strong tool to tackle the issue of game theory. Game theory is focused about the three examples. First, round board game. Second, cards. And third, competitive game.
This is an example game theory. 5 key terms for game theory. First is the Nash equilibrium. Tentative to forecast what options are to be taken if several players decide at the same time. Second is game, a problem or solution. Third is zero-sum game, a kind of Nash equilibrium in which the risk of reward of a player are diametrically opposite. This is usually observed in game with 2 players. Fourth is a player, a person or object are competitors and have a set of choice. And lastly is a player, affected when player choose positive or negative. In this problem, we are using matrix method to find the solution of game theory problem. First is to determine the strategy, how to determine the strategy, and we have to determine the minimax row and maximin column.
In this table, we can see that the minimum value for row A1 is 3, A2 is 4, and A3 is negative 4. From these 3 minimum value, we have to find the maximum value. The maximum value is 4, which is from row A2. So the minimax row value is 4. And the maximum value for column B1 is 10, B2 is 9, B3 is 5, and B4 is 7. From this 4 maximum value, we have to find the minimum value. The minimum value is 5, which is from column B3. So the maximum column value is 5. When the minimax row value equal to the maximum column value, it is a saddle point. But in this game, it is mixed strategy because of the minimax row value not equal to the maximum column value.
Determine the mixed strategy for each player by using dominant strategy. Dominant strategy can be used for simplifying the problem and to reduce the size of the game, especially in mixed strategy game.
To minimum the value, when player A choose A1, player B will choose B3. When player A choose A2, player B will choose B1. When player A choose A3, player B will choose B3. Player B2 and B4 is a dominant strategy, and we can delete column B2 and column B4. To maximum the value, when player B choose B1, player A will choose A1. When player B choose B3, player A will choose A2. Player A3 is a dominant strategy, so we can delete row A3.
Reduce matrix. After get the reduced matrix, using this reduced matrix to calculate P cofactor and P adjoints. We have to insert value in cofactor formula. For cofactor row 1, column 1, the value is 5. Cofactor row 1, column 2, the value is negative 3. Cofactor row 2, column 1, the value is negative 4. And lastly, cofactor row 2, column 2, the value is 10. Therefore, P of cofactor is 5, -3, -4, and 10.
The adjoint of P is transposed by the cofactor matrix. The row 1 transpose to column 1 and the row 2 transpose to column 2. Then we will get the adjoint of P is 5, -4, -3, and 10. After get the adjoint of P and cofactor of P, then we can calculate the optimal strategy of player A and player B. For player A, the formula that I use is the value 1 and 1 in row matrix multiplied with adjoint of P, then divide by the value 1 and 1 in row matrix multiplied with adjoint of P multiplied with the value 1 and 1 in column matrix. After calculation, the answer will be the value 1/4 and 3/4 in row matrix. It is represent the probability of player A. For player B, the formula that I use is the value 1 and 1 in row matrix multiplied with cofactor of P, then divide by the value 1 and 1 in row matrix multiplied with adjoint of P multiplied with the value 1 and 1 in column matrix. After calculation, the answer will be the value 1/8 and 1/7 in row matrix. It represent the probability of player B. The last step is find the value of this game. The formula that I use is the row probability of player A multiplied reduced matrix multiply the column probability of player B. So 1/4 and 3/4 in row matrix multiply the matrix 2 by 2, which is 10, 4, 3, and 5, multiply 1/8 and 1/7 in column matrix. After calculation, the final answer will be 285/224. Convert to 4 decimal place is 1.2723.
The conclusion is matrices can be used to assist organize information about numerous competitors' options using a combination of linear algebra and game theory. Through the process of matrix reduction, competitors can make educated quantitative decisions using the Nash equilibrium and linear algebra. Game theory is a helpful tool for keeping track of the options and calculating results. It can assist you in determining what an opponent might do and making an informed decision based on the fact you know.